In this lesson, we're going to learn why keep, change, flip works when we're dividing fractions. Okay, so here we're going to start off with our example of 2/7 divided by 5/6. Now, in order for us to show why keep, change, flip works, we're first going to solve this problem the long way. Okay, remember, fractions represent division, and vice versa. Any division problem can be set up as a fraction. So here we have a fraction divided by another fraction, but we can represent this as just one great big fraction, as 2/7 as the numerator divided by 5/6 in the denominator. I know it looks kind of weird, we have fractions within a fraction, but remember, it's really just saying 2/7 divided by 5/6. And setting it up this way is going to help us to see how this longer strategy works. The next thing that we're going to do is multiply that denominator of 5/6 by its reciprocal. Now remember, the reciprocal is just the flip of the fraction. So 5/6 multiplied by its reciprocal of 6/5. Now if we remember, whenever we multiply any number by its reciprocal, it's going to equal 1. So that denominator, once we multiply it by the 6/5, will just become a 1. Okay? Now, of course, we can't just multiply the denominator by 6/5. Whatever we do to one part of a fraction, we have to do the same thing to the other part of the fraction. So we also have to multiply the numerator by 6/5. Okay? And then that part we can just multiply across like we normally do with multiplication. The 2 times 6 will give us 12 as the numerator. 7 times 5 will give us 35. So that part just becomes 12 over 35. Okay, now we still have a fraction within a fraction. But remember, whenever we have a 1 as the denominator of a fraction, the fraction will just simplify to whatever the numerator is. So this fraction just becomes the 12 over 35. So that's our final answer, 12/35. Okay, so that's the long way of dividing fractions without using keep, change, flip. Now we're going to see how that same problem is solved the short way with keep, change, flip, and see if we get the same answer. So remember, keep the first fraction the same, then we're going to change the division sign to multiplication and flip or take the reciprocal of the second fraction. So it'll look like this. And of course now it's just a multiplication problem and we multiply across. We still get 12 over 35. Same answer, but much, much faster. So why does keep, change, flip work? First, we saw the long way of dividing fractions where we multiply the denominator by its reciprocal so that we end up with a 1 as the denominator. And then, of course, whenever the denominator is 1, the fraction is just equal to the numerator, and that helped us to get to our final answer. Then, of course, the short way is just doing keep, change, flip. It got us the same result as the long way, but much, much faster.